right. So today we're going to learn a new way to solve quadratic equations. All right. This is called solving quadratic equations with the quadratic formula. So just to refresh my memory, what's a quadratic equation? It's an equation that has an x with one exponent. It's going to have x squared, right? If it just has an x with an exponent of 1 as the highest exponent, then that would be a linear equation. But so our quadratic equations have x squareds in them, okay? We've already learned a couple methods of solving quadratic equations. The main one we learned so far was factoring. And in factoring, if I took an equation like y equals x squared plus 5x plus 6, and I was trying to solve this with factoring, that's where I found my two factors, like that this equation was equal to x plus 3 times x plus 2. And then I would set those equal to 0, and I would say my solutions are x equals -3 or x equals -2. And those would be my solutions for this equation up here. So that was the method of factoring that we were using to solve these quadratic equations. Well, the problem is that you can't always factor a quadratic equation. So the method we're going to use today is something that you'll always be able to do to solve them. Okay? And just like before, most of the time you're going to get two solutions. So here is the quadratic formula. We read it as x is equal to -b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. Okay? You guys on your SOL are going to have a formula sheet, and this formula is on there, I believe. I need to double check that. So if that's the case, we're not going to focus on having you guys memorize this formula, but I think over time you guys will get to memorize it as you use it more and more. So what letters do we see in our formula? We see a lot of A's, B's, and C's in there, right? Where are those coming from? Those will actually be numbers that are part of your quadratic equation when it's in what we call standard form. So in standard form of a quadratic equation is ax squared plus bx plus c. Now a will be some number, b will be a number, and c will be a number. Those are going to be the coefficients of the variables in your equation, right? The key here is that your equation, before you use the quadratic formula, you need to make sure it's in standard form. And there's two main parts to that. First of all, everything needs to be on one side of the equal sign, and you need to have 0 on the other side of the equal sign. All right? That's the first part. The second part is you need to go in order of your exponents from highest to lowest. So I start with my x squared, then I have my x's, and then I have my constant, which is just a number with no x's in there. Okay? So when we say down here below, our method, our first step is going to be to write it in standard form. That's what we're talking about. We need to make sure it's in standard form first. Then we're going to identify what are A, B, and C. Those are just the coefficients or the constant. We'll tell you that. We'll show you that in a second. Then we apply the formula, and that's it. These are our 3 steps for solving these types of problems. All right, and up here you get some information on different types of solutions you can get. You can get 2 real solutions. You can get 2 imaginary solutions. Sometimes you actually get 1 solution. That's a double solution. Okay, so let's look down there at example problem A. First of all, is my equation in standard form yet? What do you think, Sam? No, I'm just asking right now, is that equation in standard form yet? Standard form means that everything needs to be on one side of the equal sign and 0 needs to be on the other side. No, that's not the case, right? So I need to make this into standard form. To do that, I'm going to cancel out this 7 from that side by subtracting it away. And anything I do to one side, I have to do to the other side, right? So these 7s will cancel out. And I'll end up with 2x squared plus 5x minus 7 equals 0. Morgan, you with me? We're doing problem A from the packet, the notes packet. All right. So now it's in standard form because everything's on one side with the 0 on the other side, and I'm in order of decreasing order for my exponents. I have x squared, x to the first, and then I have my constant. All right. So now I need to identify what are my A, B, and C. So I'll come off to the side. A equals, B equals, C equals.
I can't find the page.
Okay, it's on page 14 of your notes packet.
Okay. Got it.
So A is whatever coefficient is in front of my x squared value. In this case, that's a positive 2. B is whatever coefficient's in front of my x, and that's a positive 5. And C is whatever is my constant over here. In this case, that's a negative 7. So we got to make sure that we include the sign to the left of the coefficient, whether it's positive or negative. Cool? So from this point on, it's easy. I'm going to take the A, B, and C, I'm going to plug it into that quadratic formula. So I'm going to start by actually writing out the formula, and there are some certain memory tricks that I could teach you guys to remember this formula, which I'll teach you at some point. But it's that. My solution, which is my x value that I'm looking for, is equal to negative b plus or minus the square root of b squared minus 4 times a times c. And all of that is being divided by 2a. So always take the step and actually just write out that formula first so you don't make a mistake when you're trying to transfer over your values. Morgan, we still got you? So did you copy down this formula there? All right. So now you can see I have my A's, B's, and C's, and I'm just going to plug those in. So I end up with this. X equals negative B. Well, that's a negative 5. Right? I'm using my A, B, and C values from over here. So x equals negative 5 plus or minus the square root of 5 squared. Now, if that was a negative 5, I would make sure that I put that negative 5 in parentheses before I squared it. Minus 4 times A, which is 2, times C, which is negative 7. And all of that is being divided by 2 times A, and A is 2. So 2 times 2. With me? Okay. So now from here, it's just a bunch of math and a bunch of simplifying. We're going to end up at a point where we're going to get problems similar to our warm-up problems. So I'll tell you what, just because I know I'm going to run out of space, I'm going to continue on over here. If you guys need to do the same thing, that's fine. We can do problem B on another piece of paper. All right. So now I'm just going to simplify. My first step is going to be to come through and just kind of simplify as much as I can. So I end up with x equals negative 5 plus or minus the square root of 5 squared is equal to 25, right? Minus, I have 4 times 2 is 8 and 8 times negative 7 would be a negative 56. So what I would end up here is 25 minus negative 56. And all of that is being divided by 2 times 2, which is 4. So I still have some more simplifying to do. I come through x equals negative 5 plus or minus the square root 25 minus a negative 56. I have a double negative, that becomes a plus. So that's 25 plus 56, and that gives me an 81. And all of that is being divided by 4. Right? So now at this point, these expressions are just like the ones that we started off with for the warm-up. To simplify this, I need to first look what's in my radical right here. In this case, I'm lucky because it's a perfect square in there. That's going to make it easier. So I end up with x equals negative 5 plus or minus 9 divided by 4. Okay, and this is actually one of the exact problems we did for the warm-up. So I get x equals negative 5 plus 9 over 4, or x equals negative 5 minus 9 over 4. This first one ends up being a positive 4 over 4. Second one ends up being a negative 14 over 4. And then I can just simplify those. X equals 1, or x equals negative 7 over 2. So these right there are my solutions. Meaning if I took those and put them in, substituted them in for x up here in the initial equation, they will make that equation true. And that's how you can double check to make sure they are the correct solution.